Hello everyone, this is lesson number 2 part 2 video. So it's a continuation to lesson number 2 that we started in the previous video. In this video we'll talk about the conversion statements, some of the units in both systems, English and metric, and then we'll talk about measurements and number of decimal places, number of significant figures, and exact numbers, which are all related to measurements and the degree of uncertainty in measurements. Conversion statement is relation between two units. Those units could be within the same system, English or metric, or they could be a relation between an English unit and metric unit. Here are some examples of conversion statements within the English system. The relation between mile and foot, the relation between yard and foot, and the relation between foot and inches. This was with regard to the length. With regard to the mass, also you have a relation between pound and ounce, and pound and ton. In lesson number 3, we'll be talking more about conversion statements and how we use them as conversion factors when we do calculations in order to convert from one unit to another. The second part of this video is about significant figures and the number of decimal places we have to specify when we express measurements. Just to give you an example, if we assume you go to a medical lab and you do a certain test, let's say a test of the concentration of iron in your blood, and let's say one of the lab gave you a certain reading, let's say 2 gram per milliliter, while the other lab gave you the same reading, which is 2.00, but different number of decimal places and the same unit, gram per milliliter. What is the difference between those two readings? In terms of magnitude, you can see they are the same, 2 and 2. But the number of decimal places in the measurement reflect the precision of the device that was used to perform this measurement. So for the 2.0, the last digit or the furthest digit to the right is always uncertain. So this is uncertain digit. And the same thing, the 0 here is uncertain. So what this measurement tells you that the concentration of iron in your blood could be 1.9 or it could be 2.1, for example, because the 0 here is uncertain digit, it's estimated. It can fluctuate between 1.9 and 2.1, so plus minus 0.1, while these readings tell you that it could be 2.01, also it could be 1.99. So it could fluctuate between 1.99 and 2.01. So you can see here, although the magnitude is the same, 2.0 and 2.00 has the same magnitude, but the number of decimal places reflects the precision of the measuring tool. So 2.0 could fluctuate between 1.9 and 2.1, while 2.00 could fluctuate between 1.99 and 2.01. So the 2.00, the 2 decimal places here, is more precise than the 2.0 with 1 decimal place. The last digit is always uncertain, or we call it estimated digit. Okay, let's see an example here of the PowerPoint you have on Blackboard. So let's look at the PowerPoint slides in your Blackboard about significant figures. Now all measurements, as we mentioned, have some degree of uncertainty, and that's represented by the last digit, the digit to the furthest right. Let's assume we are trying to measure the length of this line, and we have 2 rulers. One of the rulers has minimum scale of 1 centimeter. Now if you try to measure the length of this line using this ruler, we'll be trying to estimate the length here. We know for certain that the length is between 1 and 2, but we cannot tell what fraction of a centimeter should be added to the 1. Is it 1.2? Is it 1.3? Well, we can do an estimate. You can see here it cannot be 1.2. It's somewhere almost in the middle between 1 and 2. So if you think it's exactly in the middle, it might you can go with 1.5. If you think it's closer to the 1, then you can go with 1.4 or 1.3. So all those are possible answers, meaning this digit that is furthest to the right is uncertain. And that's always the digit that is uncertain. Therefore, one possible answer would be 1.4. So 1.4 has one certain digit, that's the 1. We are certain it's between 1 and 2, so the certain digit here is 1. And then one uncertain digit, which is the estimation of the fraction that falls between 1 and 2. So it could be 0.4, 0.3, 0.5. So one way to write it is 1.4 plus minus 0.1. Now let's assume we have another ruler, and this ruler, in addition to the centimeter scale, it has 1/10 of a centimeter scale, which is millimeter. So now again we are trying to determine where this line ends. Again, if we try to connect and try my best to go straight here, if we try to estimate the position of the end of this line and project it on the ruler, you can see somewhere between 1.4, this subdivision is 1.4, and 1.5, somewhere between 1.4 and 1.5. So we are certain it's between 1.4 and 1.5. We just need to estimate the fraction between 1.4 and 1.5. So this will be our uncertain or estimated digit. Now, some of you might see it exactly between 1.4 and 1.5, so you can go with 1.45, or you might see it closer to the 0.4 here, so you might go with 1.44, or you might see it closer to the 1.5. In that case, you would go with 1.46. So all those are possible answers: 1.45, 1.44, or 1.46. So now you can write down the measurement out of the second ruler, which could be 1.45. If you think that the end of the line falls exactly between 1.4 and 1.5. So you can see here we are doing the same measurement of length, but we are using two different tools. One of them is more precise because it has more subdivisions. It provides 1/10 of a centimeter subdivisions. Therefore, we were able to get to the 100th place because all measurements have one uncertain digit, certain degree of uncertainty, which will be always one uncertain digit to the furthest right. That's the digit that is furthest right. And this digit could be 0, as we can see in other examples. The other PowerPoint slide that you can find in our week lesson, and this one shows you different measurements, A, B, C, D, and E, and you need to determine the measurement here. So go ahead and pause this video and write down the measurements that A, B, C, D, and E reflect. And then after you write them down, play back this video and check if your answer is correct. Okay, so let's assume that you already wrote the measurements. So let's see what A represent. You can see here A is almost lined up with 10. So if you think it's exactly lined up with 10, so the measurement could be 10.00. And you have to go to 2 decimal places because the minimum scale here is 1/10 of a centimeter. And we always need to go one extra place. So since the minimum scale, which represents the subdivision here, is 1/10 of a centimeter, our measurement has to include 100th of a centimeter place, and the 100th of a centimeter will be the uncertain or estimated digit. So A could be 10.00 if you think it's exactly lined up with the 10. If you think it's preceding to the 10, meaning between 9.9 and 10, then the answer would be 9.99. Why is it 9.99? Because this subdivision here represents what? It represents 9.9. So the mark here is between 9.9 and 10, and it's not in the middle, so it can't be 9.95. So most probably it will be 9.99, or you can go with 9.98, but it cannot be 9.9, and it can't be 10.0. You have to go to 100th place. Okay, how about B? Now if you look at B, you can see it's somewhere between 10.7 and 10.8. Subdivision represent 0.7 and this subdivision represent 0.8. So it's between 10.7 and 10.8. If you think it's exactly in the middle between the 0.7 and the 0.8, then you'll go with 10.75. If you think it's closer to the 10.7, then you'll go with either 10.73 or 10.74. And we can apply the same on the rest of the measurements. C could be 11.51. It cannot be 11.50 because you can see it's not lined up with the 11.5, so it can't be 11.50. It's somewhere between 11.5 and 11.6, and it's closer to the 11.5. So 0.51, 0.52 or 0.53 are all possible measurements. Remember, the last digit to the right, the furthest digit to the right is the uncertain digit. It's estimated. You do estimation here. D and E, the same thing here. There are certain numbers that do not have any uncertainty, which we call them the exact numbers. Like 1 dozen is 12. There are no uncertainty. When you count things, if you have a box of eggs and you count the number of eggs and there are 8, there are no uncertainty here. It's exactly 8. And some of the conversion statements are exact, like 12 inches equal to 1 foot. Those are exact numbers. Now, as you see in the questions here, I will give you the number of decimal places expected. So go ahead now and pause this video and try to answer question number 1 and 2. And notice question number 1 has 2 parts. The first part, you need to find the measurement in centimeters. In the second part, you need to find the answer in millimeter. And the scale here is in centimeters. So this is 40 centimeter, 41 centimeter, and 42 centimeter. Now recall that 1 centimeter is 10 millimeters. So 41 centimeter is actually 410 millimeters. 42 centimeter is 420 millimeters, and so on. So go ahead and pause this video and answer those 3 questions actually. Question 2, 3, and 4. Then after you write down the answers, you can play back this video and see if you got it right. Okay, so let's go ahead and solve those problems, assuming that you already did. So when we do measurements of length, one side of the object should be lined up with the 0. So let's assume here the other side here of the object is exactly lined up with the 0 of the ruler. And we try to read the measurement on the other side of the object by lining it up against the ruler. And you can see here it's somewhere between what? Between 41.6, this subdivision is 41.6, and 41.7. This one is 41.7. So we are certain it's somewhere between 41.6 and 41.7. So it's 41.6, and then we have to estimate this digit here. And you can see here it's closer to the 41.6, so you could go with 41.63 or 41.64 or even 41.62. It can't be 41.65 because there is no way it's exactly in the middle here. It's closer to the 41.6. So all those are possible answers. Now for the millimeters, we have to go with 1 decimal place. Since 1 centimeter is 10 millimeters, so in millimeter the 41 centimeter is actually 410 millimeter. The 42 centimeter is 420 millimeter. So this is in millimeter. The end of this object is somewhere between 416, this would be 416 millimeter, this subdivision here, and 417, this one will be 417 millimeters. So it's somewhere between 416 and 417 millimeters, because each subdivision here represents 1 millimeter. So this is 410, this will be 411, 412, 413, and so on. So again, one possible answer would be 416.3 or 416.4 or 416.2. All those are possible answers to this question. Go ahead and check the solution for number 2 and 3 in the document titled Solution to the Discussion Exercises. For the homework, make sure you review the tables at the beginning of this lesson that talk about each system and the standard unit in each system, and also the table that talks about the fundamental quantities, and the table that has the prefixes and what they represent in the international system. Remember, kilo is 1000, milli is 1000, which is 1 over 1000, Santi is 100, and then check the solution in the document titled Solution to the Homework under lesson number 2. And as always, feel free to ask any questions you have. This will be the end of lesson number 2, part 2. Hopefully you found it educational.